Okay, so today we start a definition. When we say a sequence is said to be bounded sequence. Okay, so the definition: a sequence of real numbers is said to be bounded if we can find a bounded above and bounded below for the set of images. So definition: a sequence xn, a sequence xn of real numbers is said to be bounded. Real numbers is said to be bounded. Is said to be bounded sequence or bounded if, when we say sequence is bounded, we can find a number m is any number, either real number or integer, but should be positive number. We can find m greater than 0 such that the modulus of xn should be less than or equal to m for all n. All the members of the sequence should be less than or equal to m. If such a m exists, then we say the sequence is bounded sequence. Okay. So for example, if we take 1 by n sequence, so 1 by n is always bounded. Okay. So example, so if you take xn equal to 1 by n, if you consider this sequence, so if you mark all the points on the real line, so everything, if substitute n equal to 1, we go first term. If substitute n equal to 2, we get the second term 1 by 2, 1 by 3, and so on. So all the terms should lies in this interval 0 to 1. Therefore, this xn is always bounded by 1 because everything lies between cannot exceed 1. Therefore, maximum 1, minimum 0. Better we take 1 is the upper bound. Lower bound is 0, but even you can take minus 1. So within this plus 1 and the minus 1, all the sequence steps should be appear here. Therefore, this sequence is a bounded sequence, bounded by 1. Again, if you take 2 power n, suppose if you take xn equal to 1 by 2 power n, again if substitute values is always lies between, if substitute n equal to 1, actually if you substitute 0 and 1, if substitute equal to n equal to 1, you get to 1 by 2. And substitute n equal to 2, we get to 1 by 4. Therefore, even you can get the bounded by 1 by 2. Even you can take 1 by 2 or 1 or 2 or you can get taking anything, but at least you can say 1 bound. So each xn is bounded by 1 by 2. Or you can take 1, or you can take 2 or 1.5 or anything. Anyway, we got to find some positive number m such that every members of the sequence should be less than or modulus of xn should be less than or equal to m. Therefore, this xn is also bounded. But if you take xn equal to just 2 power n, so that means what? 2, 4, 6, 8 and so on. So 2, 4, 8, 16 and so on. Therefore, this is not bounded. Because if you mark all the sequence points, this is 2 and this is 4 and this is 8. This is first term, second term, third term, fourth term is 2 power 4 is 16 and so on. So therefore, we cannot find the bound for a sequence because if we found m, then the next term should be here, m plus 2 or something, we can find it. So therefore, this sequence is not bounded sequence, not bounded, but it's bounded below by the number 2, but not bounded above. So when we say is set bounded, if both bounded above and then bounded below, then we say is bounded. But this sequence is bounded below by 2, but not bounded above. Therefore, generally we can say it's not bounded sequence. It's not bounded. Okay, because it's increasing sequence. We cannot find a upper bound. Okay, therefore this is not bounded sequence. Similarly, if we take xn equal to n, so that means what is our sequence? 1, 2, 3, 4 and so on. So similarly, this sequence is not bounded. Okay, because we cannot find a bound for this number. If we take m, we can find the next sequence m plus 1, m plus 2. This is also a sequence number. So we cannot find a bound for this sequence. Therefore, this sequence is also not bounded sequence. Bounded. Okay. Now the theorem says if you take any convergent sequence, is always bounded, but bounded sequence need not be converges. We'll give example for that. So first we state the theorem. If you take any convergent sequence, the sequence is always bounded. that is every convergent sequence. Every convergent sequence is bounded sequence. Is a bounded sequence. Every convergent sequence is bounded. Every convergent sequence bounded. Why? So simple. Suppose we have a convergence sequence. Suppose xn is a sequence, it is converges. Suppose it converges to x. Okay. Now we have to prove that we have to find m such that modulus of xn is less than or equal to m. Okay. Now we know that by the definition of xn converges to x, what is the definition? If we take every epsilon greater than 0, there exists a stage n naught in n such that if you take any n greater than or equal to this n naught, modulus of xn minus x is less than epsilon. So what is the meaning of this? This xn minus s lies between minus epsilon and then plus epsilon. That is the definition of mod x. So mod x is less than a means what? This x lies between minus a and then plus e. Okay. So therefore, this modulus of xn minus a less than epsilon, therefore minus epsilon less than xn less minus x minus epsilon. Now add x all the side, therefore we get x minus epsilon less than xn less than epsilon x plus epsilon. So simply we can say modulus of xn is less than x plus epsilon. So x is a known number, epsilon is a known number. Therefore, so this is therefore now we found that modulus of xn is less than this number. So this is only true for n greater than or equal to n naught. Okay, that means so x1, x2, x3, etc. This is xn naught, and this is xn naught plus 1, and so on. So now we prove that after this, all the xn sequence terms are bounded by this number. But we have to find a unique number m. It is bounded by all the sequence number. So, but we don't know about the first previous n naught minus 1 term. So this is n naught minus 1 terms. So the remaining terms are bounded by this number. Okay. But we don't know about the previous n minus 1 terms. Then what we have to do? So therefore, we have to choose m is nothing but maximum of. So now we found that one number is x plus epsilon. Okay. Now the remaining terms we have to take the modulus. So modulus of x1, comma modulus of x2, comma etc. Modulus of xn n naught minus 1. Now you take the maximum, you will get m. So by the definition of maximum, so m is the maximum of all this number. Okay. So therefore, this in particular, if you take this number is less than or equal to m. Okay. Therefore, modulus of x1 is less than or equal to m because m is the maximum of all the numbers. Therefore, this happened. And if you take x2, x2 also less than or equal to m. Or up to you can take this x n naught minus 1 is also less than or equal to m. Now, if you take this number also less than or equal to m. But we know that this is greater than or equal to xn, where n greater than or equal to n naught. Therefore, all the sequence is bounded by this m. So we can find a such an m. Why I am taking modulus? Because we need m is positive. That's why I am taking modulus. Okay. I need this condition, modulus of x1 is less than m. That's why I am taking modulus of x1, modulus of x2, etc. Modulus of xn minus. So we have to take the remaining finite number of terms and then take the modulus. And then for the other terms, we know this is bounded by x plus epsilon. So take the maximum, we get a unique number m, which is bounded by all the sequence number. Therefore, every convergent sequence is bounded sequence. But the bounded sequence need not be convergent sequence. Can anyone give my counter example? We have a bounded sequence, but it's not converges.
xn is equal to minus 1 power n, sir.
Yeah, very good. That is a correct example. If you take minus 1 power n, so what is the sequence? If you draw in the plane, so this is a minus 1 and this is plus 1. So oscillation, this is oscillation sequence. But this sequence is bounded by 1. Therefore, modulus of xn is less than or equal to 1. Therefore, it's bounded sequence, but not converges. Therefore, this is not converges, but bounded. Therefore, bounded sequence need not be converges, but convergent sequence always bounded. So this is very important theorem. Now, we solved some problems, the exercise problem. So I already said that algebra of limits. Suppose xn converges to x, yn converges to y, then x plus y, xn plus yn converges to x plus y, and then xn into yn product converges to the product, all the things. Okay. So now we solve some more problems. So exercise. Suppose I given that first problem. Suppose given that xn is a sequence, it is converges to 1. Okay, it is given. Now I'm writing some nth term of some sequence. Now you have to tell me where the sequence converges. Suppose I'm taking the nth term of some sequence 1 minus xn, where it converges. As n goes to infinity, where it goes. And the second sequence 2xn plus 5, where the sequence converges. And then third 4 plus xn square whole divided by xn, where the sequence converges. So actually 1 is nothing but constant sequence 1, 1, 1, 1. So already we know that constant sequence 1, 1, 1, 1 converges to 1. It is given that xn converges to 1. Now we know that xn converges to x, yn converges to y, then subtraction also converges to the subtraction. Therefore, 1 minus xn converges to 1 minus 1. So that is nothing but 0. Therefore, this is converges to 0. Now look at the second one. Xn converges to 1. Therefore, 2x1 converges to 2 times 1, that is 2. And then 5 is a constant sequence, 5, 5, 5, 5, it converges to 5. Therefore, if you add these, 2xn plus 5 converges to 2 plus 5. This is nothing but 7. Therefore, this converges to 7. Now, what can you say about the limit of the third one? Xn converges to 1. Therefore, what is xn square? Again, it converges to 1 into 1. That is nothing but 1. So, if you add 4, 4 plus xn square converges to 4 plus 1. This is nothing but 5. And xn converges to 1. Therefore, if you multiply divided by xn, this converges to 1. Because xn converges to 1. Therefore, we have 5. Therefore, this converges to 5. Okay. So, this is all simple exercise. We have to use algebra of limits. That is xn converges to x, yn converges to y. Then the sum is always converges to sum of the limits. Similarly, for product, subtraction, and then division. Okay. Now the second example, second exercise. Suppose let xn is a sequence converges to the point x, and assume that all the xn's are positive. All the sequence assume all the xn's are positive for all n. Then we have to prove that the limit is also greater than or equal to 0. So how to prove x is positive? Every sequence, every term is non-negative, and xn converges to x, then we have to show that x should be greater than or equal to 0. So how to prove this one? Suppose x not greater than or equal to 0. That means what? X should be negative. Suppose x is negative, then what will happen? So this is a graph. So this is 0. So we assume that x is negative. Therefore, x should be appear. So here. So suppose I have that x here. So since given that xn converges to x, that means what? After certain stage, all the xn's are belongs to that some interval. Okay, so maybe some epsilon. Okay, so this is x minus epsilon, x plus epsilon. So after certain stage, all the sequence member lies in this interval. So therefore, it's below or less than 0, right? Therefore, we get a contradiction because all the xn's are positive. Suppose if x is negative, then since xn converges to x, then after certain stage, all the xn are belongs to that interval x minus epsilon comma x plus epsilon for n greater than or equal to some stage. After certain stage, all the xn's are belongs to this interval. That means what? All the xn's are negative, which is a contradiction because given that all the xn's are positive. Therefore, our assumption is wrong. Therefore, x should be greater than or equal to 0. So, if a sequence is positive, it converges to x, then x should be positive. So, first is, and the next one is, suppose we have two sequences, an and bn, and it satisfies some condition that an is less than or equal to bn for all n. So, an is a one sequence is less than or equal to bn for all n in n. That means what? The first term is always less than or equal to first term of the sequence. The second term of the first sequence is always less than or equal to second term of the second sequence, and so on. In general, an is less than or equal to bn for all n. And suppose an converges to some point a and bn converges to some other point b, then what can you say about a and b? Then the result says a should be less than or equal to b. Okay, so we can easily look at it. Suppose if you draw the graph, so mark some point a and b. So a is here. Suppose we have to prove these. Okay, suppose not. That means what? B is less than a. Suppose this has happened, then what will happen? So that means what? B should appear here. So that means, and we know that Bn converges to B. That means what? After certain stage, all the Bn's are belongs to this interval. So suppose we particularly take some Bn. So Bn not or Bn. So then we know that this B again An also converges to A. Therefore, after certain stage, if we take any epsilon, An's are belongs to within this interval. Therefore, this Bn and the corresponding here if you take an. So otherwise suppose there is not true that both the sequence get the same stage. Okay, so better I can take some other stage. Suppose the sequence for I fix 1 epsilon, for 1 epsilon, suppose for this, so I fix 1 epsilon and an converges to a. Therefore, we have some stage. I call the stage is n1 in n, such that after all the members of the stage, this an belongs to that interval a minus epsilon, comma a plus epsilon. So that means what? So this is a point a. So after certain stage, this is our a minus epsilon. This is a plus epsilon interval. So all the an's are here. Okay. Now again Bn converges to B. For this epsilon, we have some other stage. Suppose we take some n2 in n, such that after n2, all the Bn's are belongs to this B minus epsilon, comma B plus epsilon. So we have to prove A less than or equal to B. Okay. Suppose not, then B should be less than A. That means B somewhere here. And if we take this interval B minus epsilon, B plus epsilon, after this stage, all the Bn's are belongs to here. Bn, Bn1, Bn2, all the things. Okay, not Bn1, Bn2, N3, and so on. Now, you take the maximum of these two numbers, N1 and N2. So I take N or N0. So N0 equal to maximum of N1 and then N2. So therefore, this N0 is bigger than or equal to N1, as well as this N0 also less than or equal to N2. Therefore, already we know that after this N1, all the A N0 are belongs to this one. Therefore, in particular, A N0 is here. Again, take all N2, this N0 also bigger than N2, right? Therefore, corresponding B N0 is here. Now, what you'll get, this B N0 is smaller than or equal to this A N0, which is a contradiction because it is given that all the ANs are less than or equal to Bn for all n. But here we get some particular, not only particular, we have so many elements. Bn's are smaller, An's are bigger, which is a contradiction to our assumption. Therefore, A should be less than or equal to B. Okay. So this is simple. We got to how to prove you have to take the suppose not, and then we get some contradiction. Now, next result. So fourth one. Suppose we have a sequence. The sequence itself bounded by some number, that is A less than or equal to xn less than or equal to bn for all n in n. That means what? We have a two fixed number A and B. All the sequence are lies here. So all the x1, x2, x3, everything lies between A and B. And suppose xn converges to some point x, then that point also lies between the limit point. X also lies between A and B. So clear, right? Suppose x is here. X is here means since xn converges to x, after certain stage, all the xn's are belongs to here, but is outside from the interval AB. Therefore, that is not possible. Suppose x is here. Suppose x after this B, again xn converges to x. Therefore, after certain stage, all the xn's are after certain stage, not all the xn's. After certain stage, this xn not plus 1, all the terms within this interval, but it should be away after, it's outside from this interval, right? Therefore, which is a contrast to our assumption. Therefore, x should be inside the interval. Okay, so if you suppose a sequence is bounded by a number a and b, and suppose the sequence converges to x, that x also lies between a and b. Okay, this is very important. Now, next, suppose we have two sequences xn and yn. Suppose we have two sequences, xn is a one sequence and yn is another sequence. Now we define new sequence Sn. So Sn is nothing but maximum of xn comma yn. So that is what is S1, maximum of x1 y1. What is S2, maximum of x2 y2. So we can define maximum of x and yn is nothing but nth term. So similarly we define new sequence Tn is minimum of the corresponding terms xn comma yn. Okay, so this also converges. It's a new sequence xn. This also converges. This also converges. Okay. So why? Because we know that the maximum of two numbers. So what is the maximum of a comma b? In general, there is a formula. So what is the maximum of a comma b? Is I think a plus b minus a minus b by 2. I think so. Okay. So for example, we will check this is true or false. Suppose if we take 2 and 4, maximum of 2 and 4. So this is 2 plus 4 is 6 minus modulus of 2 minus 4 is minus 2. Anyway, take modulus whole divided by 2. So this is nothing but 2 plus 4 is 8 by 2. You will get 4. Yeah. So make us maximum is 4. So I think this is correct. Okay. So this maximum of xn comma yn is nothing but, so this is nothing but xn plus yn minus modulus of xn minus yn by 2. And we know that xn is converges. So assume that xn is converges to x, and suppose assume that yn converges to y. Then this xn plus yn converges to x plus y by algebra of limits. And this modulus of xn minus yn converges to modulus of x minus y. Therefore, this is subtraction. Therefore, you can take this one and then take divided by 2. So this converges. Similarly, for minimum. Therefore, maximum of two convergence sequences is convergence. Minimum of two convergence sequences is convergence. Provided this xn and yn are convergence. Otherwise, we cannot say xn, sn and tn are convergence. Okay. You should know the, yeah.
In that formula, you have modulus sign, sir, for maximum.
Yeah, I already said that xn converges to x. Then in front only if you take modulus of xn.
No, sir, if in the formula, if you take modulus, then you will get 4 by 2, no, sir, in that example, 2 comma 4.
2 minus 4. What is 4 minus 2 is 2. Oh, sorry. That is 2, right? So therefore, it should be plus. Then what you'll get? You'll get 8, right? So for minimum, we get a minus. So that's it. That is formula. So for minimum of a comma b is a plus b minus modulus of a minus b by 2. This is minimum, this is maximum. Maximum of two number, minimum of two number. This formula is very useful for even if you take function. So maximum of two continuous functions, continuous function, minimum of two continuous functions, continuous function. So you will study that. So similarly for sequences. So usually we are using the algebra of sequences. Sum of two sequences converges to sum of the limits, and then subtraction of two convergent sequence converges to the subtraction of two limits, and so on. Okay. Okay. Now, next one. We take the sixth one. Okay. Now, true or false? Maybe I will ask question. True or false? Suppose if xn is a sequence and we have a product of two sequences, namely xn into yn. Okay, so how we define the product? Suppose xn is the sequence x1, x2, etc., and so on, xn and so on, and yn is y1, y2, etc., yn. Then what is the product xn into yn? We have to multiply term by term. So the first term is x1, y1, comma, the second term is x2, y2, and so on. The nth term is xn, comma, y, and so on. So this is a sequence. So this is a product. So sum is, we have to sum term by term. Subtraction means what? You have to subtract term by term. So division means what? You have to divide term by term. Now, if xn and yn are bounded sequences, we don't know if it's a convergence or not, but it's bounded. Okay. Then can we say yn is bounded? Then yn is bounded. It is true. Xn is bounded and xn is yn is bounded. Can we say yn is bounded? True or false? If it is false, then you have to produce two sequences xn and yn. Xn is bounded. Okay, don't give the convergence sequence. I'm not saying any convergence, just bounded.
True, sir.
Why?
It will be bounded by the bounds of x and y.
So,
if you find the product of x.
So xn is bounded means there is some bounded. Therefore, each xn is bounded with some number m. And is given that xn into yn is bounded. Therefore, some xn into yn is bounded by some number. Suppose I am taking some capital M. Then from these two, can you how to find some number such that yn is bounded by that number? Maybe I take L. So how will you find L from this? We have to find bound for yn. No. Suppose I give example. So take xn equal to 1 by n. It is bounded, right? Bounded by 1. Now take yn equal to n. Is yn is bounded? No. Now what is the product? You get 1. 1 is a bounded sequence. Now this x and yn satisfies this. Xn is bounded, the product is bounded, but yn is not bounded. Got it? Therefore, this statement is false statement. Okay. Next, another question. Suppose, yeah, any doubt?
Sir, if xn and yn are bounded, then the product is bounded, no, sir?
Yeah, that is bounded. If both xn and yn is bounded, because we can find the maximum of the bounded number. Okay. So suppose xn is bounded by some number m1 and yn is bounded by some other number m2. If you take the product xn into yn, you can take the product of the number m1 into m2. You can find it always. Okay. So the next problem, suppose we have a sequence of positive number and suppose xn converges to x, the limit is, okay. So the next problem, suppose xn is positive, greater than or equal to 0 for all n. We have a sequence, positive sequence. And suppose xn converges to x, it is converges. Now prove that, to prove the square root of xn converges to square root of x. Okay, so this is a simple thing. Okay, we have to take this modulus of square root of xn minus square root of x. So we have to multiply and divide by square root of xn plus square root of x, and then we got to simplify. You will get the answer. Anyway, so if you take all the sequences are positive, and then xn converges to x, then square root of xn converges to square root of x. Okay. Just to note the result, you can easily prove it. And then next, true or false question. So true or false. Suppose we have two sequences xn and yn. So xn is a one sequence and yn is another sequence, and it's given that the product xn into yn converges to 0. Then can we say at least one of the sequence converges to 0? Then one of the sequence converges to 0. Either xn converges to 0 or yn converges to 0. Is it true? One of the sequence converges to 0. The product is converges to 0. From this, can we conclude that at least one of the sequence converges to 0? Now I said that product of the sequence is nothing but you got to multiply term by term. That is the product. Now tell me what is the answer. If it is not true, then produce a sequence xn and then produce a sequence yn. The product converges 0, but none of the sequence converges 0. If it is true, you have to give the proof. So usually you have to think that the statement is false and then try to give the counter example. Now I can give that sequence xn is 1, 0, 1, 0, 1, 0, and so on. So alternate is 0 and 1. Okay. So this sequence is converges. The xn.
No, sir, it's an oscillating sequence.
So it's not converges. Now I take yn is, if take the first position 1 in the xn, therefore I take 0. Now it is 0 here, therefore I can take 1. So it is 1, therefore I can take 0. 1, 0, 0, 1, 0, 1. Now again, this yn also not converges because it oscillates. Now what is the product? Term by term product. Therefore 1 into 0, 0. 0 into 1 is 0. Therefore we get 0, 0 sequence. It says 0 sequence is a constant sequence, it converges to 0. Therefore, my sequence x and yn satisfy the given assumption. Xn into yn converges 0, but none of the sequence converges 0. Even they not converges. It's oscillate sequences. Therefore, this statement is false. Even the product converges 0, but even the sequence is not converges, xn and yn. That is also possible. Okay. So any doubt in this? Okay, now another example, another problem. Problem number 8 or 9. Okay. So we have a sequence an. Suppose an converges to 0. What can you say about the sequence an power n? That means what? What is mean by an power n? So substitute what that is a1 power 1, a2 power 2, a2 power 3. You have to first you have to take the first term, second term you have to square. So original sequence is a1, a2, etc. and so on. So I am taking the new sequence a1 power 1, a2 power 2, a3 power 3, and so on. Now what can you say about the sequence? So this converges 0. Then what can you say about these sequences? This converges 0. And then why? Why the sequence converges to 0? Are the sequences bounded or not? Or it converges or not? an converges 0. So that means what? After certain stage, all the, so we have a, so we know the given that an is converges 0. So this is 0. So after certain stage, all the ans are belongs to this interval. So maybe some epsilon. So a minus epsilon, a plus epsilon. So after certain stage, I take the stages n naught. So after this stage n naught, all the ans are inside this, belongs to this interval. Now, what can you say about this an power n? So what is a1? So again, so therefore all the ans are very near to 0. So we can choose some epsilon such that which is less than 1. So therefore I can take some epsilon which is less than 1. Therefore all the ans are less than 1. After certain stage, all the ans are less than 1. Now we raise the power n to the both sides. Therefore an power n is also less than 1. 1 power 1 is nothing but 1. Therefore also this also less than 1. Therefore various approaches 0. But instead of an converges 0, suppose an converges to some other number more than 1, then we cannot say an converges to an power n is does not need not be converges. Okay, got it? So this happen only when because an converges 0. Why? Because if 0 is the ans are less than 1. This is a very important point. All the after certain stage, all the ans are less than 1, right? Therefore, an power n is less than 1. Therefore, it approaches to very close to 0. Therefore, we can say it converges to 0. But suppose this an converges to some other point. Suppose I am taking 2. Suppose an converges to 2, what can you say about an power n? Suppose 2 is here. So after certain stage, all the ans are belongs to here. So at least we can take 2. Suppose for simplicity, I am taking some ans are 2. Then an power n is 2 power n. So therefore it's increasing. So we cannot say the an power n is converges. But if all the ans are less than 1, then an power n is also less than 1. And ans are very close to 0. Therefore, an power n also close to 0. Therefore, an converges to an power n also converges to 0. Okay, got it? Any doubt?
So this is only for a decreasing sequence which tends to 0, sir?
No, not only decreasing. Maybe anything. So it may be approach. So we can approach 0 any direction. Suppose 0 is here. Okay. Suppose we have a point 0 here. So we have some sequence. Suppose I am taking A1 here, A2 may be here. I am taking A3 here, A4 here. So anyway, we can approach this direction also. So need not be is increasing, decreasing. Anyway, it approaches to 0. So a sequence that converges 0 means we cannot say it's a decreasing sequence. Okay. Maybe it contains both increasing and decreasing. Anyway, finally, this approaches to 0, this side also approaches 0. So finally, every sequence approaches to 0. That is around 0. Okay.
Okay, sir.
So if an converges 0, then an power n also converges 0 because all the ans are less than 1. This is a very important point. Otherwise, we cannot say an power n is converges. Okay, so next problem. Suppose xn converges 0, then xn square also converges 0. Suppose we have a sequence xn is converges 0 if and only if xn square also converges 0. The algebra of limits we can say directly because xn we take 2 times xn converges 0, xn converges 0, just to multiply we get this direction is simple. Okay, by algebra of limits. Now take this one. Suppose xn squares are converges 0. From this we have to say xn is converges 0. So how to say this one? So what is the relation between this xn and the xn square? So since given that xn square is converges to 0, that means what? After certain stage, all the xn squares are very near to 0. So 0 is here. Suppose if we take some interval that is so 0 minus epsilon, 0 plus epsilon. After certain stage, all the xn squares are here. So maybe 1 is here, minus 1 is here. Therefore, xn squares are less than 1. Then what can you say about xn? Is also less than 1. If you take the square root, I am going to take the square root both side. Therefore, anyway, it also lies between 0 and 1 or 1 and 1, minus 1 and plus 1. Therefore, we can say xn also converges 0. Even if xn square is converges 0, then xn converges 0. Instead of taking 0, suppose if we take some other number, we cannot say xn is converges to 0. For example, suppose I am saying that xn square is converges to 1. From this, can you say xn converges to 1? Xn square is converges to 1. From this, can we say xn converges to 1?
No, sir.
Why? What is the example? If you take xn equal to?
That alternating sequence, that oscillating sequence, sir. Minus 1 power n.
Yeah, minus 1 power
N,
n.
sir.
Yeah, that is minus 1 plus 1 minus 1 plus 1. If a square means everything we get 1 1 1. Therefore, xn square is converges to 1, but the sequence is not converges. Or you can take xn equal to minus 1 minus 1 minus 1. Anyway, we need xn does not converge to 1. We need. Okay, therefore we can take xn equal to minus 1 minus 1 minus 1 minus 1. So definitely this converges to minus 1. Okay. So please 1 minute. So if you take xn equal to -1, -1, -1, is converges to -1. And what is xn square converges? 1. Because you have to square each term. Therefore, xn square converges to, there is 1, 1, 1, 1 converges to 1. So xn square is converges to 1, but we cannot say xn converges to 1. Because sometimes it converges to -1 or sometimes not converges. Okay, therefore, this result is not true in general. But if xn converges 0, if and only if xn square is also converges to 0. So both the direction is true if the limit is 0. Okay. Now, another problem, 11th problem. Suppose we have two sequences. Now we define new sequence. Suppose xn is a one sequence and yn is another sequence. Now we define the new sequence zn. So how we define? First I take the first term is the sequence term x1. The second term is the first term of the yn. That is x1, y1, x2, y2, x3, y3, and so on. So this is a new sequences. Okay. Now what when this sequence converges? When the zn is converges. If it is converges, then what can you say about xn and yn? So suppose, okay, I am writing statement, you fill that. So zn is convergent.
It converges to the same number, sir.
If and only if this one converges to
Xn and Yn converges
both
to same
xn,
number.
xn both xn and yn converges to the same number. Converges to same limit or same number. Okay. Why? So we can easily prove it. Suppose zn converges to some, we assume that zn converges to z, some point z. So z is here. So after certain stage, all the members are belongs to this interval z minus epsilon to z plus epsilon. Therefore, zns are nothing but just in terms of xn and yn. Therefore, all the xi's are near to this one. All the yns are also near to this one. Therefore, both xn also converges to z, yn also converges to z. Similarly, xn converges to z, yn converges to z. Therefore, all the x and yns are near to z after certain stage. Therefore, zn is nothing but xn's are yn. Okay, therefore, again, the zn is also near to z. Therefore, both the ways are very simple. Okay, this is a new one. Okay. Suppose I am taking new sequence. Suppose we have our next. This is actually 12th problem. Suppose we have a sequence xn. Okay, is given sequence. Now I define new sequence sn. I'm taking only the odd position, that is x1, x3, x5, x7. So I'm taking only the odd subscription, that is x2n minus 1. And take tn is the even position, that is x2n for n greater than or equal to 1. Now we have two sequences, sn and then tn. Then what can you say about this sn? Is converges or not? Okay, suppose xn is convergent. Suppose xn is converges to some point. Suppose xn is converges to some point x. Then what can you say about this sn and then tn? So if and only if both
Sn and Tn converges to x, sir.
sn also converges to x and tn also converges to x. It will not change anything. This is separate sequence. Xn is converges to, because this is a subsequence. Therefore, Sn also converges to x, Tn also converges to x. So similarly, suppose the even terms are converges to x, and then the odd terms also converges to x, then the original sequence converges to x. This is if and only if. It's very useful for solving some problems. Okay. Suppose in a sequence, even if you consider only even position, we know the limit, and then the odd position also you know the limit. Then if both are same, then original sequence converges to the same point. Okay. Now 13th question. Suppose we have a sequence xn and it converges to 0. Suppose we have a sequence xn and xn converges to 0. Okay. Now I define some function sigma. It's a bijection function from n to n bijection. So bijection means what? Just we have to should be 1 1 and R2. So now we define new sequence yn. Yn is nothing but x suffix sigma of n. So for example, 1 maps to suppose I am taking that sigma 1 goes to some 5, sigma 2 goes to some 7, and sigma 3 go to some number. Suppose I am taking 3 and so on. So what is yn sequence is what is x1 is nothing but s suffix sigma of 1 and then x sigma of 2 and so on. Okay, this is nothing but x suffix 5. We know what is the x term. Xn is given. So first we got to write the x fifth term. And then what is sigma of 2? Sigma of 2 is 7. Therefore, we have to write the x seventh term. And see, x sigma 3 is nothing but x3. Sorry, x3. And so on. So this is our sequence yn. So just you got to permute the position or you interchange the position somewhere. Something, okay, to you to do. Now, what can you say about the sequence yn? Is converges or not? If it is converges, what is the limit? And given that xn is converges to 0. So that means what?
Then yn also 0, sir.
Yeah, yn also converges to 0. Even if you change anything, after certain stage, since xn is converges to 0, so after certain stage, all the members are very near to this 0. Okay, therefore, so only the finite number of terms may be away from 0. Only finite number of terms. So all other terms are very near to 0. Therefore, if you consider this yn, maybe the finite number of terms are maybe 0 or not 0, somewhere away from 0. If you take suitable stage such that all the x's belongs to this yn also 0. Okay. Okay. Now we have a problem. Next problem, 14th one. Suppose we have a sequence xn. I am defining xn equal to 1 minus 1 by 2 into 1 minus 1 by 3 into and so on into 1 minus 1 by n plus 1. This is our sequence. Nth term is this one. Then what can you say about this xn? This xn is convergent or not? Or show that xn is convergent. Show that the sequence xn is convergent. Okay, what is x1? So x1 is nothing but just 1 minus 1 by 2. This is nothing but 1 by 2. And what is x2? X2 is nothing but 1 minus 1 by 2 into 1 minus 1 by 3, the 2 term. So this is nothing but this is 1 by 2 and this is 2 by 3. Therefore, this is nothing but 1 by 3, right? And what is x3? X3 is the product of first 3 term. That is 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 4. So what you'll get? So this is actually 1 by 2. This is 2 by 3 and this is 3 by 4. So finally what will get? 2 2 cancel, 3 3 cancel, we get 1 by 4. So therefore it converges, right? So in general actually what will get xn? Xn is the product of this one. If you simplify these, what is xn? x1 is 1 by 2, x2 is 1 by 3, x3 is 1 by 4. Then in general what is xn?
1 by n plus 1.
1 by n plus 1. Clearly, where this converges as n goes to infinity is 0. Anyways, converges. Therefore, this sequence is converges. Okay. Now, a very important thing. Suppose I give some number. Can you produce a sequence converges to the number? Suppose the 15th problem. Okay. Suppose I am giving 2. Can you produce a sequence converges to 2 except constant sequence 2 to 2 except 2 to 2. Can you produce another sequence converges to 2? Can you produce a sequence converges to 2 except the constant sequence? So can you take this 2 plus 1 by n is converges to 2 because 1 by n converges to 0, 2 converges to 2, therefore the sum converges to 2 plus 0, that is 2, right? So we can produce this sequence. We can find so many sequences. Either you can do 2 minus 1 by n or anything. Anyway, we can find a sequence converges to 2. Now, question is, suppose I give some real number, general real number, a is a real number. We can find a rational sequence. We can find a sequence xn from rational numbers such that xn converges to that number a. And similarly, we can find a irrational sequence, that is yn belongs to that irrational numbers, and this yn also converges to. If you give any real number, we can always find a rational sequence converges to that given number, and always we can find a irrational sequence converges to the same number. So what is the case? Suppose there are two cases. Suppose you are taking a real number. So the first case is, suppose the number is rational. Then we can find two sequences, one sequence from rational sequence, one sequence is irrational sequence, converges to the a. So if you take, what is the rational sequence converges to a? A plus 1 by n is converges to a. Because a is a rational number, 1 by n is a rational number, sum of two rational numbers is a rational number, therefore this sequence is a rational sequence, converges to this rational number, okay, we done it. But we got to produce irrational sequence converges to this rational number. Can you produce a irrational sequence converges to this one? Simply we can take square root of 2 by n. Is a rational sequence or irrational sequence? It's a irrational number. Because root 2 is a irrational number, even 1 by n is a rational number. If you multiply some irrational number, this becomes a irrational number. Therefore, this root 2 plus root 2 by n is a irrational number. I am adding a. Now this converges to a because this 1 by n converges to 0. If you multiply root 2, again it converges to 0. But a is a constant sequence, a converges to a, therefore the sum is converges to a. Similarly, second case, suppose you are taking irrational number, therefore that is a is not a rational number. Now you have to produce a irrational number converges to the same thing. So what is the, if you take a plus 1 by n, since a is an irrational number, 1 by n is a rational number, anyway the sum is irrational number, is converges to a. Therefore now we find that irrational sequence converges to this irrational number. Now we have to produce the rational sequence converges to this irrational number. What is the rational sequence we can find here? That should be converges to the irrational number a. For example, simplicity I am taking root 2. So for simple case, I am taking a equal to root 2. Can you produce a rational sequence converges to root 2? What is the sequence? That should be a rational sequence. Each sequence term should be rational number, but it converges to root 2. So what is the sequence? How to find that sequence? Okay, that is simple. So we know about this number, integer part of any number, integer part of x, this square bracket of x. Okay. So what is the meaning of this? So for example, if we take square root of integer part of 1.2 is nothing but just 1. You take only the integer part. This is the integer part of x which is less than or equal to x. Because this one is one integer part of 1.2 is value is 1 is always less than or equal to 1.2 because this value is 1. Therefore, this is the integer part of x is always less than or equal to x, greater than or equal to x minus 1. So always lies between this. Okay. Now think about it. What is the rational sequence we can find which converges to, suppose here in general I am taking 2. In general I am taking a. So we know this result. If you take any real number, the integer part of x always lies between x minus 1. So suppose this is x and this is x minus 1. So in between x minus 1 and x, can you find an integer here? Or, okay, there is a ceiling and the floor is there. Okay. So if we take x equal to 2.5, what is the integer part of x? Is 2. What is x minus 1? Is 1.5. Therefore, this 2 lies between 1.5 and then 2.5. Therefore, this is happened. Correct? Now, using this, we can find a number. So how to find it? Now I can write. So I need a sequence converges to A. Okay, now I am considering n times A. Now I am considering the integer part of n times A. So by the definition, this integer part of n times A less than or equal to NA and then greater than or equal to, we can take NA minus 1. So instead of x, I am taking NA. Got it? Now divided by n all the side. Therefore, we can cancel n, we get a minus 1 by n. If you multiply n both sides, 1 by n. So this side is you get NA, integer part of NA by n. And this side is less than or equal to n and cancel, we get A. Okay. Now I am taking, this is our required sequence xn. Therefore, what you will get? This xn is bounded above by A, bounded below by A minus 1 by n. Now look at this xn. This xn is a rational sequence. Why? Because this is an integer, this is an integer. Therefore, xn is a rational sequence. Therefore, xn is a rational number, lies between this one. And there is a sequence. There is a theorem. That theorem is called sandwich lemma, or sandwich lemma, sometimes called as Q's lemma. Says that suppose we have 3 sequences satisfying this condition. Zn less than or equal to xn less than or equal to yn for all n. Suppose these 2 sequences converges to a point x, then the middle sequence also converges to x. That is sandwich. Okay. So as this is a constant sequence, this converges to A. And this goes, n goes to infinity, this 1 by n converges to 0, therefore this also converges to A. Therefore, the right hand side, left hand side converges to 0, the middle term also converges to A. Therefore, we get a rational sequence converges to this irrational number. Okay, got it? Is very important. So given any real number, we can always find a rational sequence converges to that real number. We can always find a irrational sequence converges to that point. Okay, so that is very important. Okay, anyway, I can stop now. Tomorrow we will discuss. Thank you.